G'day team, welcome back to yet again another video on differential calculus and more specifically kinematics. So we're going to learn today how to interpret the signs in a sign diagram of my displacement function, my velocity function, and also my acceleration function. So for displacement s of t, if it's greater than 0, it's positive and it's right of the origin. S of t equals 0, it's at the origin. S of t less than 0, it's negative and it's left of the origin. Okay. For my velocity, if it's, when I find my sign diagram, this a value is when my velocity equals 0. So that means it's at rest. If it's negative, it's moving to the left. And if it's positive, it's moving to the right. And for acceleration, when acceleration equals 0, the velocity is either the maximum, the minimum, or constant at any point. We can work that out. If it's negative, the velocity is decreasing. And if it's positive, then the velocity increases. Okay, so there's a fair bit of information there. And the more you sort of utilize these sign diagrams, that's when life comes easier and it'll start clicking. So a bunch of things that you may be asked to find. So if you're asked to find the initial conditions of my object, then I set t to be equal to 0 in my s, v, and a function. If I want to find when the object is at the origin, I make s equal to 0 and solve for t. If I want to find whether it's stationary, where it reverses direction, or the max/minimum displacement, I set v to be equal to 0 and solve for t. Then if I want to find whether it's at a constant velocity or where the max/minimum velocity are, I want to set a to be equal to 0. So depending what the question asks is what sign diagram you use and what equation you use to solve for t. So if v of t and a of t are the same, both positive or negative, the speed of the object is increasing. If v and t and a of t signs are opposite, the speed of the object is decreasing. Okay, and we'll see hopefully an example of that. So s of t equals 2t cubed minus 9t squared plus 12t take 5 centimeters. Find v of t, a of t, and draw sign diagrams for both. Now that's a pretty meaty question. So v of t, so this is a, v of t is s prime of t, so f dash of t, which is 6t squared take 18t plus 12t. Now we can solve that quadratic, so pull out a factor of 6, t squared take 3t plus 2t. Now that is going to give me 6t take 2, t take 1, and we want to set that to equal 0, so that means t equals 1 or 2. Obviously, in context of the question, if I get a negative time, don't use it. You can't have negative time, so we reject that solution. So let's find my sign diagram. So t, this is my v of t, so make sure you label it so it's easier for you. 1, 2, let's put 0, 3 on 2 and 3. If I put those back into my function here, I've got positive, negative, negative, that gives me a positive. I've got positive, negative, positive, that gives me a negative, and then I've got positive, 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 so positive like that. So there's my sign diagram. Let's now find a of t, which is v dash of t. So I've got 12t minus 18. Now to solve that for 0, 12t equals 18. T equals 18 on 12, or what's that going to be as a fraction? 3 on 2. All right, so let's now create my sign diagram for that value. Now this is my a of t. So 3 on 2. So let's put in 0 and 2. If I put in 0, I've got a negative. If I put in 2, I've got a positive, so there's my sign diagram. And that's part A done. Part B, find the initial conditions. Now going up here, initial conditions was just set t equal to 0 in all of them. So initially, I need v of 0 and I need a of 0. Now, in all of these, it's super easy because it's just the last term. Now, there shouldn't actually be a t there. It's just the last number is going to be our solution because all of these, the rest of the terms have t's. So s of t is -5 and centimeters because of units. My velocity is going to be 12, so positive 12 centimeters per second. And my acceleration is going to be -18 centimeters per second squared. So initially, object is at 5 centimeters left of the origin because it's negative. Because my velocity is positive, it's traveling right at 12 centimeters per second and is accelerating in the opposite direction at 18 centimeters per second squared. Okay, so that little sentence just kind of sums everything up. Part C, describe the motion of the particle at time equals 2 seconds. So we're pretty much doing the exact same thing, but at 2. So V of 2, A of 2 equals. So I'm just going to quickly grab my calculator out and calculate this. So 2 times by 2 to the power of 3 minus 9 times 4 plus 24 minus 5. So that gives me -1. So -1 centimeters. V of 2 is 6 times by 4 minus 18 times by 2 plus 12 is 0. And A of 2 is 24 minus 18, which is just 6, so centimeters per second and centimeters per second squared. So we can pretty much copy this down and just change a few words. So instead of initially, we've got at t equals 2 seconds, object is 1 centimeter left of the origin. It is stationary. Okay, so my velocity is 0. Object is stationary. And it's accelerating not in the opposite direction. So we can go accelerating rightwards at 18. It's not going to be 18 though, it's going to be 6 centimeters per second squared. Okay, so the sentences don't change too much, you've just got to put context behind them. So part D, find where the particle changes directions. Now, changes directions also is the same as reverses. So that's when V equals 0. So I look at my velocity sign diagram. So at t equals 1 and 2. So using sign diagram for V of t, object changes directions at t equals 1 and 2 seconds. But we need to know where they are at that time. So we need to find S of 1, S of 2. Now S of 2 we already found to be -1 centimeters. S of 1, if I put 1 into my displacement, 2 minus 9 is negative 7, plus 12 is positive 5, minus 5 is 0. So it's also changing directions at 0 centimeters. All right, finally, we want to draw a motion diagram. So for a motion diagram, we want its starting point. So our motion diagram is actually only going to be in terms of S, okay? So I'm going to put 0 here, 1, 2, 3. I think, initially I was at negative 5, so that's probably not going to work too well for me. Let's do 2, 4, 6, negative 2, negative 4, negative 6. So initially at t equals 0, I was at negative 5. So I'm going to put my object at negative 5 somewhere. Then I'm moving along rightwards, and at t equals 1, I turn around. Now at t equals 1, I'm at 0, so I turn around here, and then I also turn back around at minus 1. So I'm going along, I turn around at minus 1, and in this case, I don't have an endpoint, so I put an arrow on the end. If I had a motion diagram between t equals 0 and 10, I would have to find S of 10 and put that in. So your key features, t equals 0, t equals 1, t equals 2. I need my starting point, I need my 2 turning points, and maybe an end point if required. But that is essentially a motion diagram. So hopefully that helps. You've got an example now. Have a go at some questions, looking back at what the question's asking for. What do you have to make equal to 0? All that good stuff. See you in the next video.